I'm really excited to be kicking us off today, and I'm very excited because I'll be talking about Tamagotchis and ES6 generators. So quick recap, I'm Jen. I'm a front-end architect at a company called The Wing. We are based out of the United States, and we build co-working spaces that are women first. If you want to reach me, the best place is Twitter. My handle is girlcode, girl with a U. And at the end, I'm definitely going to post these slides. So if you miss something, do not worry. The slides are going to be posted. OK. How many of you had a Tamagotchi? OK, a good number of you. So if you aren't familiar with what a Tamagotchi is, it was a really popular digital pet in the 1990s. It was a handheld device like this. And the game was that a Tamagotchi would appear on the screen in a shell, it would break out of its egg, and then you were responsible for raising the Tamagotchi to adulthood. So it would go from a baby like this to a teenager to an adult. And then when it became an adult, you didn't know what type of Tamagotchi you were going to get, so that was like the fun surprise of it. Now, I had a Tamagotchi growing up. In fact, they were even banned from my school because they made a beeping sound when they needed something from you. And unfortunately, that meant a lot of my Tamagotchis didn't make it. Rest in peace. But I really, really loved this game growing up, and I decided I wanted to make a web-based version of it. So my web-based version includes an SVG shell for the game. The controls are actually made out of divs. And then the screen is made out of the canvas element. Now, if you've never worked with the canvas element, it's really easy to work with. You're going to query the DOM for the canvas element. And then to draw on the canvas, you're going to request the type of context that you want. So in this case, we want 2D, not 3D. And then you're going to give it an image to draw and some XY coordinates that I'm really not going to get into right now because they don't matter as much. And you're going to do draw image, that image to the screen. So you can see that my Tamagotchi is drawn to the screen. And then for the animations in the game, I decided I want to use a sprite sheet. So below is the sprite to bounce the Tamagotchi. So if you go 1, 2, 3, it'll go up. So if I need to animate this, I need to draw it at 0, and then 200, and then 400 pixels. So that's going to bounce the Tamagotchi up. And then I would do those coordinates the opposite way to go down. Now, you'll also notice that I'm using context.clear between the drawings, and that is to avoid this situation. So if you don't clear between your drawings, they just draw right on top of each other. So you always draw and then clear. And so the way this code is written, this isn't going to work. So I'm pressing one of the controls, and as you see, the Tamagotchi is just one of the frames being drawn. And that's because we're drawing and clearing the context so quickly that you only see the last frame being drawn. You're not going to see the other ones. So what I actually need to do with this animation is that I need to delay it. So the original game has this really old school, like choppy animation. So that's what I want to do. I want to delay it like that. And I can use set timeout to do this, and this works. So now you can see the Tamagotchi is bouncing up and down. I'm going from frame 1, 2, 3, and then back for a full bounce. But this has actually created a problem for me, because now all of my animations are async. So how do I know when an animation has completed? How do I know when I can safely kick off another animation without overriding the previous one? The truth is I don't. I'd have to sort of measure and keep track of how long these animations take. And that's just not sustainable for a game that is full of animations. What I want is to resolve an animation and then handle another animation. And this sounds a lot like a promise. Now, promises represent eventual values. So I can animate inside of a promise, resolve it, and because it's eventable, I can then kick off another animation. So for the first version of this game, that's exactly what I did. I used promises for every animation. I made a general purpose animate function that takes in a draw function and the milliseconds for the delay. So animate always returns a new promise, and inside of that promise, an inner function runs the draw function. And we delegate resolving the promise to the draw function. So if the draw resolves the promise and returns true, we're done. Otherwise, set timeout is called with the inner function, and another loop of this occurs. So here we're going to use the animate function to create a bounce up animation. We're going to pass a function that draws the correct frame. It's going to clear the context. And it's going to increment the current frame. And when the current frame is greater than the frame count, the promise is resolved and we return true. Now, this would stop the function from setting another loop via set timeout. So now we can create a simple bounce function using our bounce up animation and a bounce down animation using the same animate function. And as you can see, our Tamagotchi is bouncing. Now, with those animations out of the way, what we need to work on is creating the main game loop. So when you're not interacting with the Tamagotchi, it goes through a loop. It sort of bounces up and down, moves a bit this way, moves a bit that way, bounces up and down. And this is what it's doing when it's idling, when you're not doing anything with it. So to set up that, we're going to create a loop function, and we're going to call the idle animation. And when that completes, we're going to call the loop function again. And I thought, this is great, totally fine, except I actually created more problems. So the first issue that I noticed is what I refer to as venable hell. So once upon a time, we used to use async calls on the front end with callbacks. And this created the dreaded triangle of doom, aka callback hell. But one of the issues I noticed when creating this game was that promises actually don't alleviate callback hell. You're still in hell, it's just a different looking hell. So, the left side is a more realistic version of how these animations might work. I might need to pass in some information to functions or check information to make a decision, and this gets just as unwieldy and as unmanageable as callback hell. This doesn't resolve that issue for me. And, I actually really love promises. I think they're really great. But when you're using them for very large-scale async work, the ease of promises really tends to break down. So, the point of the Tamagotchi is that the user can interact with it. And this is where we come up with our second issue that I found, because venable hell is one thing, this is a completely different thing. Now, it's looping, it's idling. I need to interrupt that at some point, because you're going to have to feed the Tamagotchi at some point or play with the Tamagotchi to up its happiness. The whole game is actually about you interacting with the Tamagotchi. So what I need to do is I need to suspend the idle animation in favor of a user-generated event. So if you want to feed the Tamagotchi, I got to stop idle, and then you can feed the Tamagotchi. So here, I've added an array to hold pending events. The loop function is going to check if there are any pending events, and if there are, the handle event function is run, and the loop is terminated. So handle event is going to take the first event off the queue, and it's going to run it. And when it's complete, we're going to restart the loop. And if there's another event in the queue, handle event will get called again. Otherwise, we're going to continue the loop until the next event. And unfortunately, the problem that I found was that this just doesn't work. So I'm requesting to feed the Tamagotchi, but the feed animation is actually delayed until the idle animation completes. So this can be upwards of 7 to 8 seconds, and this is not going to work. What I actually need to do is cancel the promise that runs the idle animation. Except you can't cancel promises. Promises are unbreakable vows. You can throw errors in promises, and you can catch those errors, but you can't actually cancel a promise. All the attached .then functions are going to fire. What I want actually is to pause an animation and then yield to an event. And this sounds a lot like a generator. So generators are amazing because they're code that can be paused. All of the code that you write is run to completion, except for generators. All the code that you write, usually once it starts, it just goes from top down to the bottom. Even if you're doing async work, it's thrown onto the event loop and it's going to come back around. You can't cancel it or pause it. But with generators, you can do both. So let's take a look at them. This is a generator, and I know it's a generator because of the asterisk next to the function keyword. So that turns a function into a function generator. Now, inside the function, you're going to notice a special keyword called yield. And yield means pause in the generator world. To use the generator, you're going to call it, and that's going to return to you the generator object. And on that object is a method called next. And when you call next, you're going to get back an object with two keys on it, value and done. If there is a value to the right of the yield statement, it's going to return that as the value. Done is going to tell you whether the generator is done or not. And in this case, it's not because there are more lines to run. Okay, so we're going to call next again. See, now we're not actually yielding a number. You don't have to yield a value if you don't want to. Yield just means pause generally. So in this case, the value is undefined. And again, we're not done yet. So done is false. We call again. Now we're yielding back 3. So the value is 3. But done is still not false because we've paused at yield 3. So once we call next again, now the generator is going to say, yes, we're actually done. So we didn't yield a value, and now done is actually true. Now, you can also pass values into a generator. And this seems a little bit weird at first, because you'll notice that the first time we call next, we're not passing in a value. We're actually doing it in the second call. Now, the reason that this happens is that inside of this generator function, once it hits the yield statement, it pauses. And that includes assigning things to variables. So const num equals hasn't actually been called yet. It actually yields, it pauses before you actually assign the variable. Now, when I call next again, if I provide a value to it, it's going to take the place of the previous yield. So now const num equals, that yield is replaced with a 2, and now we've assigned the variable. And then we also run yield 2 plus num. It pauses there and gives us back the value 4. After that, yield 4 plus num, and now we're getting back the value 6. Then we call next, and we're done. One of my favorite things about generators is that you can create infinite generators. So here, to avoid having to call next and then next again and pass in the 2, we can just straight up pass in as an argument for the number 2. So right away, when we're calling the generator, we can pass something in. And you'll notice that inside of this, we have a while loop. Now, normally doing while true is going to run continuously and crash our browser. I know because I've made that mistake more than once. But in this case, actually, that's not going to happen. So this is really interesting. The generator is actually going to pause the while loop. And it's not going to run continuously and crash our browser. And every time that this gets called next on it, we're running the while loop again. So it pauses it, and when we call next, it's going to resume. And because while is true, it's going to give us back the number. Now, I can just keep calling next on this for as long as I want. There we go. It's just going to keep generating numbers for me. It's never going to stop until I explicitly tell it to stop. But you can create infinite generators that always give you something back. Now, you can also call a generator from inside of another generator. To do that, you're going to need the yield star expression. To illustrate that, I have a generator function called outer and a generator function called inner. And you'll notice that outer is calling inner with the yield star expression in front of it. So, same as before, I'm going to call the generator to get the generator object. Then I'm going to call .next on that generator. And the first time, this totally makes sense. What we expect to happen happens. We're yielding 1, so we're getting back the value 1, and of course, we're not done yet. But when I call next again, you're going to notice that we're not yielding back a function. What we're actually doing is we're going inside of the inner generator. So yield star is a delegate. And that means when it encounters a yield star with a generator next to it, it's actually going to start calling .next as if that generator was part of the outer generator. So now when I call .next, I'm actually getting yield A, value A, from the inner generator. And this is going to continue until the inner generator is complete, and then it's going to go back to the outer generator. So it's a seamless calling of .next, even though you're putting together two different generators. Now, the other thing that's really cool, and the thing that I really wanted out of the generators, is that you can cancel them. And you can do this one of two ways. So the first is that you can call from the outside. That's right. Sorry, I'm having a hard time with the clicker. So here, again, we have a while loop. So it should say while true, and it should run for forever. But I'm actually going to cancel the generator from inside of the generator. And I'm going to do that with the return statement here. So the first time I call next, we get what we expect. But as soon as it hits a return statement in a generator, it's going to cancel it. And you'll notice that it just goes straight to done true. And of course, we're not yielding a value. Same thing when we call .next, we've canceled this generator. So there's no way for it to keep running anymore. This is actually done completely. Now, the second way to cancel a generator is from outside of that generator. Again, a while loop. This should run for forever. But as soon as I call generator.return on it, it's going to cancel it. So you can see again that done is now true. And this is really interesting that you can cancel a generator from inside or from outside of the generator, because resuming the generator occurs on the outside of the generator only. So generators are paused via yield and restarted via next. But a generator cannot call next on itself. If I never call next on this generator, it will never yield 2. And this is something I really struggled with when I started to convert my game from promises to generators, because I wanted to know who runs the generator. If control happens outside of the generator, something has to be telling it to resume itself. Who's pulling the strings? And that's how I learned about coroutines. Coroutines are really cool. I'm a big fan of them. They are a general control structure whereby control flow is cooperatively passed between two different routines. And this doesn't make a lot of sense, but it will soon, because the generator can't resume itself. You need a cooperative partner to help out. So something has to take control away from the generator, but then also hand it back to the generator to run its own code. So this function is a basic example of a coroutine. So it's going to take in a generator, and it's going to call it, which returns the generator object. And then the inner function next response calls the generator's next method. So this is going to actually start up the generator, which will run until it encounters a yield statement. At that time, the generator is going to return an object with the value key and the done key. And next response is going to evaluate whether the generator is done or not. And if it's not, it's going to call itself with the value from the generator's response. And the loop is going to continue until the generator is done. So the coroutine is the cooperative partner to the generator. The coroutine function passes control to the generator, and when the generator pauses, control goes back to the coroutine. And these two functions cooperatively pass control until completion. So now I can rewrite the bounce up animation as a generator and use a coroutine to actually run it. But this code actually suffers from the same problem I had in the beginning. So it's just going to go too fast. I think it's playing. There we go. So you can see it's doing what it did in the beginning, which is just it writes too fast. And that's because generators aren't really going to resolve my issues with set timeout and promises. I actually still need them to be able to handle delays. But generators don't really care if you're using promises. So it's not going to wait for each promise to resolve and then resume itself. It can't resume itself, but a cooperative partner could. So I can amend the coroutine to handle async requests. Instead of calling next response, we're going to call a handle async function. We're going to pass it the value of the generator's response, which is a promise. And now we can actually prevent the generator from resuming until the promise is resolved. And when it's resolved, we're going to call next response, which will resume the generator. So with our amended coroutine, these functions are now equivalent. Previously, we chained promises together for the animation. Now we can yield promises, and our cooperative partner, the coroutine, is going to handle resuming the generator when the promise is resolved. Now, you can do more than yield promises with coroutines. You can yield all sorts of async things, including callback functions. You can also yield generators themselves. And there's a really great library called Co if you want to play around with this. It's highly recommended. Coroutines are very powerful. And the reason that they're so powerful is that they allow you to think sequentially about async code. So because the coroutine is your cooperative partner in handling the messy business of chaining promises together, you can write your code as if it ran sequentially. So for the second version of this game, I rewrote all of the animations with promises and generators. So what you're seeing here is the same idle animation, but with generators and promises. And it's run by a coroutine. And I had two goals with the rewrite. I wanted to be able to pause animations, and I wanted to take advantage of thinking sequentially about async code. So to do that, I started with rewriting the function that delays the animation. So this is our async function, and it doesn't need to hold the animation itself. It just needs to delay with a promise. That's its sole responsibility. So when this function is called, it returns a new promise that resolves when the timeout is complete. I also broke out the context clearing into its own function and the drawing of the image into its own function. So now we can combine these new functions to replace the previous animation function, and we're going to do so inside of a generator. So we'll clear whatever was previously on the canvas, then we're going to draw the new frame, and these get to occur synchronously. There's no problem with these needing to be async. They can occur synchronously. But what is async about this is the delay. So we're going to yield the delay. That's the asynchronous part. And then we're going to pass off handing it to our coroutine. So our coroutine will be handling the asynchronous part of this, but this feels very synchronous. And now I can redraw the dislike animation. So this is an animation that has 2 frames. So you can see this gets a lot cleaner than the code that I had previously. And then here is our Tamagotchi saying, like, nope, I don't like whatever's going on. I'm running out of time, but very quickly. We're going to rewrite the main game loop. So we're going to take advantage of canceling the generator. Our loop generator function will be run by a coroutine, so we can rely on that to handle the asynchronous stuff. We're going to create a variable to save a status of the generator. Is it done or not? And we're going to preset the animation to idle. We'll use a while loop to create a never-ending generator, and this way the game loop can continue for forever. If we have a pending user event, we're going to delegate to the event using yield star, and whatever the event yields will be passed to the coroutine. Otherwise, a second while loop will handle running the animation. So as long as the animation is not complete and there are no pending events, this loop will yield the generator's values to the coroutine to handle. And these are promises, so the coroutine is going to handle the chaining. But if the animation is done or there's a pending user event, the loop is going to terminate, stopping the animation generator from running again. And we're going to reassign the animation to an idle generator so it starts from the beginning, and we're going to reset done to false. So on the next iteration of this loop, pending will be true, and we'll handle the user event instead. So this is the generator for the feed action. It's going to evaluate if the Tamagotchi is hungry or not. If it's not, it's going to delegate future next calls to the dislike generator, which will run the dislike animation. Otherwise, we're going to decrease the hunger count and use yield star. We delegate to the eat generator that runs the animation. Okay, so now we get to see everything together. So we're idling. We're going to feed the Tamagotchi, give it a good burger. And you can see it canceled the idle animation straight away, and you got to see the Tamagotchi eating right away. Then it goes back to idling, and then we're going to feed it again. And this time we're going to give it some candy. Great. Immediately cancels the idle animation and runs the candy animation, feeding it candy. One more time. We're going to try and feed it one more time, and it's not happy. It does not want any food. So you can see this now works. And that is all I have for you. The code is at this GitHub if you want to check out the code itself. I'm still in the process of writing the Tamagotchi, but you can check out what's there already. And come see me at the break if you would like some stickers. I have some Use React and Wing stickers that are React focused if you use React. And thank you.